Hi guys, welcome back to our mathematics tutorial. So this is question number 14 of finding derivatives of trigonometric functions. So my name is Peter C. Jr., your math tutor. So in this problem, we want to solve for y equals to, we want to find the derivative of y equals to x cos of x raised to the power x plus x sine of x raised to the power 1 over x. Like we said in previous video, this is not the case that we use the power rule. No, you don't use the power rule for this kind of problem. You don't use the power rule because the power is not a real number. The power is not like 1, 2, 3, -4, and so forth. The power is a function. So based upon that, our target is to get this x from up here and bring it downward. That's our target, to get this 1 over x from here and bring it downward. So to do that, because there are three terms here, 1, 2, and 3, two terms on this side, and then you have one expression right here, we cannot take the ln on both sides just like this. Because if you take the ln on both sides, it means on this side you will have the ln of this function plus this function, and we do not have a property that will assist us in showing that this x comes down and then this 1 over x also comes down. We don't have that property for logarithm. So based upon that, we deal with these functions separately. So we consider, like we said in previous lecture, let arrow be the first function, x cos of x raised to the power x. So if we take the ln on both sides, the ln of arrow, so we take the ln on this side, this power will drop. Because if you have the ln of a raised to arrow is equals to arrow the ln of a. So if this is our a and this is our arrow, this arrow now will come behind the ln. So it's going to be x ln of x cos of x. Now we also know that the ln of a times b is equals to the ln of a plus the ln of b. So we can apply the same property right here. So we have the ln of arrow is equals to x, the ln of a, let's say of x, plus, so this x is a factor, so we go along with it. So we have x, the ln of cos of x. Now we can find the derivative. So this now gives us 1 over arrow times the derivative of arrow, which is arrow prime, equals. So this one we use the product rule because you have x and you have two functions being multiplied. So we hold x and differentiate ln of x is just 1 over x times the derivative of x is just 1. So this x can cancel this x, plus we now hold ln of x and differentiate this x, we get 1. Plus, we come on this side, we hold x and differentiate ln of cos of x, it gives us 1 all over cos of x times the derivative of x is just 1. Plus, we hold now ln of cos of x and differentiate x, we also get 1. So we can just simplify it. So arrow prime, remember this arrow is going to be multiplied by this expression. So we have arrow, and then this is now 1 plus ln of x plus x all over cos of x plus the ln of cos of x. So arrow now is this expression, so we can bring in arrow value, which is x cos of x raised to the power x, and then times 1 plus the ln of x plus x over cos of x plus ln of cos of x. So we hold on to this and do the next one, and then at the end of the day we can combine the both of them. So the next one is x sine of x. So we have x sine of x raised to the power 1 over x. So let's replace this with some p. Then we differentiate. So we have the ln of p is equals to the ln of this expression. So this power drops 1 over x, the ln of x sine of x. So like we did previously, we can separate these two. So we have the ln of p equals 1 over x, the ln of x plus 1 over x, the ln of sine of x. Then let's find the derivative. So we have 1 over p times p prime or equals. So this function and this function, we must find the derivative separately. So let's assume we hold the first function, or we can even rewrite this function as x raised to the power minus 1. Because if it goes in the numerator, the power changes to minus 1. So let's rewrite it as x raised to the power minus 1, for instance. So we can now hold this ln and differentiate this x raised to the power minus 1. So x raised to the power minus 1 is minus 1 times x raised to the power minus 1 minus 1. Because the rule says we must subtract 1 from the power, so it's minus 2. So we hold on to this ln of x. Then plus, we hold this x to the power minus 1 now, and differentiate ln of x, we get 1 over x times the derivative of x is just 1. Plus, we come on this side, so we can do the same thing to just rewrite this expression, x to the power minus 1. So if we hold on to this and differentiate this x to the power minus 1, we're going to get minus 1 times x raised to the power minus 2, because subtracting 1 from the power, times the ln of sine of x, plus we hold x to the power minus 1 now and differentiate ln of sine of x. It gives us 1 over sine of x times the derivative of sine of x, which is now cos of x. So we can now simplify. So we have p prime. Now this p will be multiplied by this expression. So remember, p. Now in this first term, we just have minus x raised to the power minus 2 ln of x plus, now you can simplify these two, right? X to the power minus 1, x raised to the power positive 1. If it goes in the numerator, it becomes x raised to the power minus 1. So when the bases are the same, you add their power. So it gives you x raised to the power minus 2. But this negative, okay, it's in the next term. So we have minus x raised to the power minus 2 ln of sine of x. And in the next one, we have plus x raised to the power minus 1 cos of x all over sine of x. But then this p is x, so we can just rewrite it as x sine of x raised to the power 1 over x, p prime. So there's our p, just rewrite it. Now we can find our final answer. It's going to be a long something, very long. So the final answer is just the derivative of this plus the derivative of this one. So the derivative of the first one was what we had here, and the derivative of the second one now is just this expression. So let's continue. So we have y prime now, the derivative of this one. So it's x cos of x raised to the power x times 1 plus ln of x plus x all over cos of x plus ln of cos of x. So that is the first, plus differentiate that one now. This was what we got. So now this becomes x sine of x raised to the power 1 over x. So this power is negative. We can send it in the denominator. So it becomes negative ln of x all over x squared plus, so this is also negative. We can send in the denominator. So this is plus x raised to the power, sorry. So it's 1 all over x to the second power. Likewise with this one, minus ln of sine of x all over x squared. And then this one also goes in the denominator, so it's plus. Now, cos over sine is just cot. So this is cot of x all over x. So if we even like, this is 1 over cos. So 1 over cos we know is secant. If we like, we can rewrite this as x times secant of x. It's still the same. It doesn't make any major change. So let's write it properly. Ln of x plus 1 over cos is secant, so it's x secant of x, and then plus ln of cos of x. So this is actually our final answer. It's kind of long something. This is our final answer. This is how we find a derivative of these types of functions. So for our teachers, these are exam problems for your students. So you can test your students with these so that at least you crack their brains more. So now you can practice this particular problem. It's similar, I just changed a few things. So this cos of x, I replaced it with sine of x. This sine of x, I replaced it with cos of x. That's all I did. That's just all. So you can now practice this one, use the same step, and find the derivative of this function. Thanks all so much for watching, and see you in our next lecture.